Hey everyone, so today we're going to continue with your circles chapter. So we're going to talk about a formula that you probably know, which is the area of a circle formula. In order to find the area of a circle, the formula is what you see right before you, which is pi r squared. So just remember that r is for radius, and that no matter where the radius is, they're equal to each other, and that you square and pi is a number, which is approximately 3.14. Sometimes we leave pi in the answer. When we leave pi in the answer, like this, it's called exact. So this might be an exact form. When it's asking for an approximation, we use 3.14. So let's practice with that formula. A circle has diameter of 12 inches. So it has 18 inches. Find the exact area. So this problem actually reminds us using pi. So we want pi in the final answer. And then we want an approximate area rounded to the nearest hundredth. So we want two different answers. We want exact and we want approximate. So remember that your formula is area is equal to pi r squared. We want to list the information that we know. We know that the diameter is equal to 18. Unfortunately, my formula does not have diameter in it. It has radius. So I need to know the relationship between diameter and radius. Diameter is bigger than the radius. So if the diameter is 18, the radius is half of that, which is 9. So the diameter is equal to 2 times the radius. That's the relationship between them, okay? So now that I know what my radius is equal to, now I can use my formula. So in order to find the exact area, so this is going to be for exact, I'm going to do area is equal to pi. My radius is 9 squared. 9 squared is 81. So my exact area is 81 pi, and this is in inches. And since it's area, it's squared. So this is the exact answer with pi in it. Now, for an approximate area, we're going to use 3.14, right? And so I'm going to do 81 times pi. So for the approximate, I'm going to do area is 81 times 3.14, right? Because I'm going to replace pi with 3.14, and I'm going to see what I get. And I definitely am going to use a calculator for that because I can't do it off the top of my head. And then I get area, this is what my calculator gives me, 254.34. I'm going to check, that is to the hundredth, so that is good. And this is inches squared. So I now have an exact area and I have an approximate area. So what do you think the difference is between an exact area and an approximate area? So go ahead and answer that. Okay, let's take a look at another one. We want to figure out what the radius is of a circle, given that area is 225 pi inches squared. So this problem is a little bit different, and it looks like we're working backwards. So we know area, meaning that we know that this formula was used, pi r squared. We're looking for r, so we don't know what r is equal to. Pi is not a variable, pi is a number, so we're not solving for pi. And we know that area is 225 pi inches squared. So what that means, wherever I see area in my area formula, I'm going to replace it with 225 pi. So now my equation becomes 225 pi, right? I can't forget the pi, equals, and then I'm going to write the rest of my formula, pi r squared. So you should notice something pretty cool here. Technically, you're solving for r, so technically you'd be dividing by pi on this side. So pi cancels out. And guess what? When I divide by pi on this side right over here, these pi's also cancel out. So now I have no more pi in my answer, which is good. So I have 225 is equal to r squared. Now let's think here for a moment. You want to solve for r, which means that you want to square root. So we're going to square root both sides to cancel that r squared. Hopefully you have this memorized, but in case you don't, the square root of 225 is 15, so that means that my radius is 15 inches, and I am all the way done. If I'm not sure, I can plug in 15 in for radius right here into this formula and see if it comes out to 225 pi. So how do these terminologies relate to each other? So let's talk about this a little bit. The diameter, I like thinking about circles in terms of my favorite circle, which is pizza. So the diameter is like any time that someone, when they cut your pizza, they like slice all the way through to make the pizza slices. All of these are diameters, right? The circumference, since it goes all the way around, the circumference would be your pizza crust, since it goes all the way around. Okay, so that's kind of how I think about that vocab. Additionally, whenever you have a slice, so for every slice that you have, it creates an angle, which we call a central angle because it's coming from the center of the pizza. So here's a central angle. This is another slice. That's another central angle. Here's another central angle. So any angle created by the pizza slice is a central angle. For example, if the pizza cutter is really good, then all the central angles are equal to each other. So you know the relationship between radius and diameter. A diameter is equal to 2 radius. Remember, that's what we said. So from here to here is a radius, and then from here to here is another radius, and together it makes a diameter. So each one of these little slices right here, if I'm cutting this way, is a diameter. So hopefully you can see that green marking there. Each one of those is a radius, and then plural is the word radii, however you want to say that, and all of them are equal to each other in length. Every single one of them is equal to each other in length. So let's talk about our next concept. So this is going to set up our next little concept here. The relationship between arc length and sector and our pizza. First, we're going to start with circle sector. So go ahead and you're going to work on a couple of practice problems on just area, and then we're going to talk about circle sector.